There are quite a lot of different chemicals that are actually present in seawater. Most obvious these are sodium and chloride ions, which make the water salty. Alongside these are sulfates, magnesium, calcium, potassium, as well as to a less extent carbon, bromide, iron, cobalt and copper. These levels haven't always been the same during the history of the Earth. This change has some real-world implications today. And going back about 2.4 billion years, the oceans contained an awful lot more iron than they do today. This iron was dissolved in the water until the proliferation of what's known as cyanobacteria, which use photosynthesis to generate energy and produce oxygen as a byproduct, to eventually produce snowball Earth, which I mentioned in another video. The oxygen created by the cyanobacteria first became bound up with the iron in the oceans, creating iron oxide before going on to dominate the atmosphere of the early Earth. The iron oxide, or rust in the oceans, unlike iron, can't actually be dissolved in the seawater, so the iron oxide fell out of the oceans, was deposited on the seafloor in layers, much like many sedimentary rocks. These iron deposits are broadly known as the banded iron formations. The iron in the sediment is then mixed up with other particles falling to the bottom of the ocean around the same time, produce layers of rock in many places around the world, rich enough in iron ore to make it the source of the majority of iron ore that's mined around the world. These banded iron formations can be found in Australia, Brazil, Canada, India, Russia, and the USA. In Europe, however, these banded iron formations are relatively rare. Instead, the iron ore comes from gabbros, a form of volcanic rock associated with granite deposits. These gabbros contain iron in the form of magnetite, which also may contain titanium and other elements brought up from deep within the Earth. While ocean-based banded iron ore formations are rare in Europe, the same general method of production of iron at the bottom of bodies of water also took place in bogs and wetlands, creating what are known as bog ores, a useful source of early iron in Europe, especially for the Romans and the Vikings, as well as later for some early settlements in America. Though with the coming of the Industrial Age, the bog ores, which had been relatively easy to extract, couldn't produce the volume of ore that was needed to meet demand. So instead, iron ore mining switched to magnetite and gabbros in Europe, or the banded iron in other locations around the world.